Hi students, today we are going to discuss about Newton's second law. This law states that the force acting on an object is equal to rate of change of its momentum. F vector equal to dp vector divided by dt. In other words, we say whenever the momentum of a body changes, there must be a force acting on it. So you already know momentum P is equal to mv. So P vector equal to mv vector. The mass of the object remains constant during the motion. So you substitute the momentum value in the second law. So you get F vector equal to d of mv vector divided by dt. M is a constant. Take it outside. So m dv vector divided by dt. You already know this a vector equal to, that is acceleration equal to you already know a vector equal to dv vector divided by dt, rate of change of velocity. So you write ma vector. So f vector equal to ma vector. So in this case, if there is an acceleration a vector on the body, then there must be a force acting on it. This implies that if there is a change in velocity, then there must be a force acting on the body. The force and acceleration are always in the same direction. So this Newton's second law and was predicting shift from Aristotle's idea law of motion. According to Newton, the force need not cause the motion, but only a change in motion. Okay, so the Newton's law is valid only in the inertial frame. It does not valid non-inertial frame. It requires some modification. We use in a non-inertial frame. This law is modified. In SI system of units, the unit of force is measured in newtons. So the symbol you already know, the Newton symbol is capital N. So Newton is defined as the force which acts 1 kilogram of mass to give an acceleration 1 meter second power minus 2 in the direction of the force. Now we are going to see Aristotle versus Newton's approach on sliding object. Newton's second law gives the correct explanation for the experiment on the inclined plane. Okay, you already know this inclined plane, this one. Okay, so initially we give some force, apply the force on this sphere, then it will move on, going on a smooth surface. Okay, but in the case of Aristotle, every moment you give some force on the object. So it travels some distance and stops because of the frictional force acting in the direction opposite to its velocity. This frictional force reduces the velocity of the body and it becomes to zero. The velocity becomes to zero and brings to it rest. The object comes to rest. As per Aristotle's idea, as soon as the body reaches the bottom of the plane, it can travel only a small distance and stops because there is no force acting on the object. See this diagram. This is a astrolite, that is external force needs to be applied to move an object with constant velocity v. So in this case the surface is you consider as a there is friction surface, but in this case Galileo and Newton, there is no net force on the object when it moves with constant velocity. So you give an external force and velocity move in this positive x-axis direction, but frictional force act in opposite direction. So net force equal to 0. Then Newton's third law. This diagram, take this one. This diagrams, that is a hammer and a nail. Okay. So hammer beat this nail. What happened? F21 vector forces acting on the nail, and also this nail some force is exerted on hammer, that is F12 vector. Okay, and this one, ball bouncing off the wall, that is fall, F vector wall on the ball. Okay, and it bounces, then walking on the floor with the friction. Okay, so action, that is action is force exerted by the feet on the ground. So reaction is the force exerted by the earth on the feet. So you can work this reaction is not take place, we are not going to walk. So these two action and reaction is opposite. So you write F12 vector equal to minus F21 vector. So third law assures that the forces occur as equal and opposite pairs. Okay, an isolated force or a single force cannot exist in nature. So Newton's third law states that for every action there is an equal and opposite reaction. This is a 2-mark market. Here, action and reaction pair of forces do not act on the same body but on two different bodies. Okay, two different bodies. Action is takes place one body and reaction gives the other body. So two different bodies. Any one of the forces can be called as an action force and the another one is a reaction force. So Newton's third law is valid in both inertial and non-inertial frames. First and second law, it is valid in inertial frame only. Then this action reaction forces are not cause and effect force. It means that when the object 1 exert force on the object 2, the object 2 exert equal and opposite force on the body 1 at the same instant. The next one is discussion on Newton's law. So this Newton's law are vector laws. So F vector equal to ma vector. This is the vector equations. It is equal to 3 scalar equations. Okay, there is Fx Cartesian coordinate system. That is Fx I cap plus Fi j cap plus Fz k cap equal to max I cap plus may j cap plus ma z k cap. Okay, comparing both sides. That is fx I cap equal to max I cap. I cancel, so fx equal to max. This is the acceleration along x direction depends only on the component of force acting along the x direction. And Fi equal to May. The acceleration along y direction depends only on the component of force acting along the y direction. And Fz equal to Maz. The acceleration along z direction depends only on the component of force acting along the z direction. Okay, these equations infer that the force acting along y direction cannot alter the acceleration along x direction. Okay, in the same way, Fz cannot affect Ay and Ax. This understanding is essential for solving problems. Okay, then the acceleration experienced by the body at time t depends on the force which acts on the body at that instant of time. It does not depend on the force which acted on the body before the time t. Okay, so we can write f of t vector equal to m of t vector, ma of t vector. So acceleration of the object does not depend on the previous history of the force. For example, when a spin bowler or a fast bowler throws the ball to the batsman, once the ball leaves the hand of the bowler, it experiences only a gravitational force and air frictional force. The acceleration of the ball is independent of how the ball was bowled. Okay, that is with a lower or higher speed. In general, the direction of a force may be different from the direction of motion. Though in some cases, the object may move in the same direction as the direction of the force. It is not always true. Okay, then a few examples for that. The first one is a force and motion in the same direction. Take this tree. So when an apple falls towards the earth, the direction of motion, then that means direction of velocity of the apple and the that of force are in the same downward direction. Okay. And next one is the force and motion not in the same direction. The moon experiences a force towards the earth. Not only moon, planets experience a force towards the sun. Okay, but it actually moves in elliptical orbit. In this case, the direction of force is different from the direction of motion. Okay, see this one. The moon direction elliptical path, but direction of Moses is tangential. Okay, in the elliptical motions of tangential directions. And then force and motion in opposite direction. If an object is thrown vertically, okay, the direction of motion is upward, but gravitational force is downward. So V and F is opposite. Then next example, zero net force, but there is motion. Okay, force is zero, net force is zero, but there is motion. When a raindrop gets detached from the cloud, it experiences both downward gravitational force and upward air drag force. Okay, as it descends towards the earth, the upward air drag force increases, and after a certain time the upward air drag force cancels the downward gravity. It means the two forces are equal. So the net force becomes zero. Then on the raindrop moves at constant velocity. Okay, this velocity is called the terminal velocity. Okay, till it reaches the surface of the earth. The raindrop comes with zero net force, therefore with zero acceleration, but with non-zero terminal velocity. Okay, do you understand this one? Okay, this one. First, air drag, gravity. Air drag is a small force, and air drag force increases. Then, in this case, gravity and air drag equal. So, raindrop get constant terminal velocity. Okay, no force acting on the raindrop. You multiple forces F1 vector, F2 vector, etc. Fn vector act on the same body, then the total force, net force F net vector is equivalent to the vectorial sum of the individual forces. So F net force equal to Fn vector plus F2 vector plus etc. Fn vector. See this one, vector addition of forces. So C vector equal to resultant C vector equal to A vector plus B vector. So according to the Newton's second law, F net vector equal to MA vector. So in this case, the direction of acceleration is in the direction of net force. For example, bow and arrow. Okay, bow and arrow. F1 and F2. This is the bow, and arrow is the net F net force. Okay, net force. So vectorial addition. Okay, F net, that is equal to F1 plus F2. F net vector equal to F1 vector plus F2 vector. The next one is Newton's second law can also be written in the following form. Since the acceleration in the second derivative position of the position vector of the body. So A vector equal to d square r vector divided by dt square. The force on the body is. So substitute this A vector value. F equal to ma. So F vector equal to m into d square r vector divided by dt square. So from this equation, we can infer that Newton's second law is basically a second order ordinary differential equation, and whenever the second derivative of position vector is not 0, there must be a force acting on the body. Okay, if next one, if no force acts on the body, then second law, it means what? That is F vector equal to 0, no force act, F vector equal to 0. So you already know what is that? F vector equal to ma vector. So A vector equal to dv vector divided by dt. So this becomes 0. So you write m dv vector divided by dt equal to 0. So in this case, v vector equal to constant. It is essentially Newton's first law. It implies that the second law is consistent with the first law. However, it should not be thought of as the reduction of second law to the first when no force act on the object. Newton's first and second laws are independent laws. They can internally be consistent with each other but cannot be derived from each other. Okay, do you understand this one? They can be internally be consistent each other but cannot be derived from each other. The next one is Newton's second law is cause and effect relation. But you already know Newton's third law is not a cause and effect. But the second law says the cause and effect relation. Okay, force is the cause and acceleration is the effect. Okay, so you write ma vector equal to F vector and dp vector divided by dt equal to F vector. Okay, why? Because cos is right in cos is, which one is cos? Force is cos. So you write in the right side. So ma vector is right in, that is effect is right in left side. Okay. The next one is the applications of Newton's law. Free body diagram. Free body diagram is a simple tool to analyze the motion of an object using Newton's law. Okay, so what is the free body diagram? That is, identify the forces acting on the body. Represent the object as a point. Okay, sun and earth, you already know that is a huge particle, sun and earth. Okay, huge object, but we take a point mass. You take a point in the sense this type. This is a point, the book point. Okay, draw the vector representing the forces acting on the object. Okay, for example, a book of mass m is at rest on the table. Okay, what are the forces acting on the book? First we calculate that one, and next one, what are the forces exerted by the book, and draw the free body diagram for the book. What is the force acting on the book? So in the case, so downward force, that is gravitational force acting on the book, and normal contact force exerted the surface of on the table on the book, it is upward, it acts upwards. So take a point mass, book is a point mass, so dot, and this is mg is downward force, normal force, that is upward force act opposite direction. Okay, do you understand this one? So according to Newton's third law, there are two reaction forces exerted by the book, that is, the books exert an equal and opposite forces on the earth which acts upwards. The book exerts a force which is equal and opposite to normal force on the surface of the table acting downwards. And third one, the free body diagram of the book. This one is a free body diagram of the book. Okay, do you understand this one?